So today we are going to discuss about the topic line coding. First, what is line code means? It is used for a data transmission of a digital signal over a transmission line. So the process of coding that is chosen to avoid a overlap and distortion of signal. Main thing to avoid an overlap and distortion of the signal, such as inter-simple interference. So what are the properties of line coding? So coding is done means we can make more bit transmit on single signal. So the bandwidth used is reduced. So for a given bandwidth, the power is efficiently used. So next property, the probability of error is reduced. So error detection and the bipolar has a correction capability. So power density is favorable for us. The timing content is also adequate. So long strings of ones and zeros also avoided to maintain a transparency. These are the properties of line coding. So what are the types of line coding? So here there are three types of line coding. What are they? First one is unipolar, polar and bipolar. These are the three types of line coding. Unipolar, polar, bipolar. Okay, these are the three types of line coding. First one is unipolar, second one is polar, third one is bipolar. So what is unipolar? Is called on off keying or simply OOK, on off keying, OOK. Is simply called as on off keying. See the presence of pulse that represent 1, presence of pulse that represents 1 and the absence of pulse that represents 0 in unipolar. Okay, so here there are two variations in unipolar signalization. So the presence of pulse represents 1 and the absence of pulse represents 0. So there are two variations in unipolar signalizing. First one is non-return to 0, that is NRZ. Second one is RZ, return to 0. First one is non-return to 0. Second one is return to 0. So what is unipolar non-return to 0? NRZ means. So here a high in data is represented by a positive pulse called mark. So here a high in data that represents a positive pulse, that is called mark. So which has a duration of T0, that is equal to the symbol bit duration, is equal to symbol bit duration. So here a low in data input has no pulse. This is called unipolar non-return 0. The waveform should be this is the example waveform for unipolar non-return 0. So what are the advantages of unipolar non-return 0 means? It is simple. First thing, it is simple. It is having a lesser bandwidth is required. So these are the advantages of unipolar non-return 0. So what are the disadvantages as well as disadvantages of unipolar non-return 0 means? Here no error correction done, no clock is present, loss of synchronization, especially in long strings of zeros and ones. Then presence of low frequency components that causes signal droop. So these are the disadvantages of unipolar non-return 0. So next one is what is unipolar return to 0, that is RZ. Unipolar return to 0. So in this type, a high in data, that is called mark pulse. Mark pulse. So here the duration T0 is less than symbol bit duration. Okay, symbol bit duration. So it also immediately return to 0 that shows the absence of pulse during the remaining half of the bit duration. So let's draw one thing. In unipolar RZ, so what are the advantages of unipolar RZ written to 0? It is also simple. The spectral line that presents the symbol rate can be used as a clock. What are the disadvantages? Here also means no error correction. It occupies twice the bandwidth of unipolar non-return 0. The single droop is caused that place where the signal non-zero at 0. So next, polar signalizing. In polar signalizing, that is two types. One is polar non-return 0, another one is polar return 0. So in polar non-return 0, the high in data that is representing the positive pulse, low in data represents the negative pulse. So advantages of polar non-return 0, also simple, low frequency components are present. Disadvantages means no clock present, no error correction. Single droop causes the places where the signal is non-zero at 0 Hz. So in polar representation, high in data through a mark pulse. So the duration T0 is less than symbol bit duration. Same concept. So half of the bit duration that remains high. So immediately returns to 0, shows the absence of pulse in the remaining half of the bit duration. So here for a low input, negative pulse represent data, but in 0 level it remains the same. In the other half, the bit duration. It's clearly explained there what are the advantages. It's also simple, no low frequency concept. Disadvantages is no error correction, no clock present, occupies twice the bandwidth of polar non-return 0. Single droop cause the places where the signal is non-zero at 0 Hz. So in what is bipolar signalizing? It is an encoding technique having a 3 voltages, positive, negative and 0. In bipolar, having 3 voltage levels, positive, negative, 0. So the signal is called duo binary signal. It's called duo binary signal. So for an example of alternate mark inversion, that is AMI, the voltage level gets transmission from positive to negative or from negative to positive. So having an alternate of ones to be of equal polarity. So a 0 will have 0 voltage level. Okay. So it is also having two types. One is bipolar non-return 0 and another one is bipolar return 0.